introduce myself. So hi everyone, I'm Chris Saxon. I'm part of Stephen Feuerstein's Oracle Developer Advocate team and part of the answer team on AskTOM. It's my job to help you get the best out of Oracle database and hopefully have some fun whilst doing so. So with that in mind, I've got some really cool, exciting stuff coming up for you. The new features which will be coming or planned to be coming in 20C of Oracle database. So let's just bring the slides back up. So hopefully you can see my slides now. And as I said, we're going to be talking what's coming in the future of Oracle database. So I do need to show the safe harbor statement here and kind of do, disclaimer. This is all, stuff we have planned. It doesn't mean we're definitely going to do it. This is what we've got coming in the pipeline. So bear that in mind. Things may change between what I talked about now exactly and the final release product. So we're talking about stuff that's still in progress. Please keep that in mind. That said, there's still some fundamentals of this which should be fairly common and stay fairly stable when it's eventually available to you. So there's quite a few new SQL features coming in the upcoming releases of Oracle database. I've picked out 3 which I think are really exciting and interesting, and are probably going to be ones that you actually use more in your day-to-day job. There's a whole bunch of others, but I think they're a bit more esoteric and you're less likely to use them. So the 3 key things we're going to look at are SQL macros, windowing clause extensions, so analytic functions, how they work, and some enhancements to set operators. And we'll start off talking about SQL macros and discuss kind of common business question that you might have. So quite often you might want to be asked a question like, find all the items where the purchase value was greater than $50 or something like that. So you want to find all the high value purchases, whatever that might be. And the table records the unit purchase price and the number of units as separate columns. So you need to multiply those together to find the total value that we purchased. So how do we do that? Well, we need to write a SQL statement that looks a bit like this. We need to take the unit price, multiply it by the quantity, find those where it's greater than 50. So that will give us how many order items there are that exceed that value. So this is fine, it kind of works. But this is where programmers who come from a non-SQL or non-database development background start to kind of chime in and go, well, hang on, we've got a function here. We're multiplying something, 2 columns together. Shouldn't we make that a function, a reusable component? After all, we're likely to do this thing in several different SQL statements. We might want to show it in a report. We might want to filter it in the where clause, and so on and so forth. So, one of the programming principles, don't repeat yourself or make reusable components. What do? We think, okay, well, let's create a function. We'll create a little function which just returns the product of those 2 things, multiply the quantity by the price. All well and good, right? All sounds nice and easy. Until that is, we stick it in our where clause. So now, instead of doing the multiplication, call the function, and now we've got a reusable component. So if we ever redefine how that calculation works, we can just go into that function and change it for everyone who's accessing it. Sounds great, but there's a problem, which I think hopefully many of you will be familiar with. We try and execute this, and it's going to take a while, quite a while. So it takes like 15 seconds here, and my table here had a couple of million rows. So, a couple of million is not trivial, but still, we should be able to execute the query much faster than that. So at this point, we start scratching our heads as developers going, well, how do we make this faster? How do we speed this up? And that's when, you bring in DBA and they kind of go, never do this, like never call PL SQL in SQL. And, this is like one of the first things you're taught or bashed around the head with when it comes with SQL performance and using PL SQL in SQL functions. So why is this? Anyone in chat, tell me why we shouldn't do this. All quiet on the chat today? Okay. Yep, Stu Ashton, straight in context switching. So the SQL engine and the PL SQL engine, or they're separate engines for processing SQL and PL SQL. So that means when we have a PL SQL function, we're running our SQL statement, we need to go over to the PL SQL engine to run that function, calculate the result, pass it back to the SQL engine. And particularly when we do this in the where clause, we end up doing this backwards and forwards and processing a lot, basically for every single row. This adds an awful lot of overhead to our processing. And this isn't great, because now we've kind of got a trade-off. We go, well, do we have reusable components that we can put in our SQL statements or accept bad performance, or is performance king? Does performance all that matter, and we have to kind of forget some programming principles that we learned before we learned SQL and so on? So how can we do this, or what can we do about it? I can see there's some good suggestions coming in, like making it a deterministic function and a function-based index, use a pragma UDF, and Sven is already way ahead of me. He's seen my slides, I guess. So we said we should never do this until we come on, next slide, there we go, SQL macros. Okay, so this is one of the big things that is coming in plan for 20C, and SQL macros change this whole paradigm on its head, or change how this all works. If we change that function from a regular PL SQL function and make it a macro, we brought the execution right down to just over a second. And all we've done is tweaked with the definition of the function, how we've defined it. We don't have to worry about this pragma UDF and things like that. So why does this happen? How does this work? And so on. So I'll kind of walk through some examples of how SQL macros work. So the idea behind a SQL macro is, instead of it being a function which takes some arguments, does some action on them, calculates some results, and returns the answer back to the caller, the SQL macro returns a string, which is an expression, and that becomes part of the final SQL statement. So calling a macro doesn't actually execute what's in there. It just returns some string which becomes part of your final SQL statement. So I'll show you how this works in a minute. So before we get into that, important thing to know about SQL macros come in two types. There are scalar SQL macros, and you can use these pretty much everywhere you would use a regular PL SQL function. So in your select clause, your where, your group by, your order by, so on and so forth. And this essentially returns an expression which calculates some kind of function, basically, is the idea here. So we've got scalar SQL macros, but you can also have table SQL macros, and these go exclusively in your from clause. And the idea behind these is they return a query, so you can create kind of parameterized views or polymorphic views. Another fancy sounding term there, right? So we'll walk through, how these work, but I'll start with scalar macros because they are the more basic example. So question from Stu, can scalar macros be used in DML? Again, the answer is, can you use just a regular PL SQL function? If the answer is yes, then the answer is probably yes. I mean, something like the values clause of your insert, yeah, you could do it there. So I'm not aware of any restrictions at the moment, but things may change exactly. But basically, anywhere you can currently call a PL SQL function which returns a value, then you can use a scalar macro. So that includes DML. Okay, so let's start with our scalar macro. So I've changed the definition of that function ever so slightly. So I've changed the return type, so now it returns rather than number of varchar, and it's got this SQL macro clause, and we'll put in there scalar or table to define which it is. And the key thing to note here is, now instead of returning the calculation, this is actually a string. Notice it's got the quotes around it. So this just returns some text. And when the database passes this SQL statement, look at this function, extract it out essentially, and this then becomes part of your SQL statement. So if we take, for example, you write this, you call the get item value, that's the code you're going to write. what the database actually executes is this. It takes that expression out of it and places it in. So a couple of things related to this. So someone was asked, I think it was you, Stu, about what this means in terms of what you would see for your cursors. So when I say the database execute this thing at the bottom here, you basically never see that, okay? If you look in $SQL and so on, you'll always see this function call that you did. It's only if you start really playing around doing the lovely 153 trace, which does the SQL expansion, that you'll see this as the real thing that actually gets executed. So when you're looking in the various dictionary views, it's exactly the same as what you're looking at, the SQL statement you wrote, basically. So it doesn't create different cursors for these, that kind of thing. I mean, if you think things like the pivots and unpivot clause, really, actually, under the hood, the database converts them back to the longhand way of writing those pivots. So it's a similar principle here. You never get to see the longhand version of the pivot itself. You only have to dig through the internals to find that out. So you always see the statement that you wrote, basically. Okay, see some questions coming in. So let's have a look at these. So Sven, can we use SQL macros to solve the column equals parameter or column or parameter equals null problem? Yeah, I guess so. So if you're saying pass a column, say is null check or is greater than test, and automatically expand that out into that expression, if that's what you're asking, Sven, absolutely, you can do that. You can say null safe check or whatever you want to call your function or macro and do that expansion out for you. Absolutely, you can do that. Okay, if that's not really helped explain, Sven, let me know if there's something else you're looking for. So from Edith, does the macro run at parse time or execution time? So it happens when you parse the SQL statement. So when you submit the query to the database, it kind of does all this resolution, figure out what the real thing that it's actually doing is, and then it sticks with that. So it's not kind of dynamically changing every time. Greg, cool, but sounds lovely to debug. I'd say good point, Greg, yes. It also sounds lovely to maintain, as does every dynamic SQL. Okay, does macros calc on the client side, or is it calcs in the PJ? So it's calculated exactly the same way as this SQL statement. So look at this SQL statement in the bottom. How would the database do that? Obviously, there's various ways. The exact answer will depend on what's going on, but it is all running in the database engine, okay? It's not doing some of it on the database and doing some on your client itself. All happens in the database engine. So I hope that answers your question there. But just imagine you ran this statement itself. So John, I saw a talk on SQL macros by Connor. It's like cool but scary, yes. So yes, there is a lot of power with these, a lot of power to get things and show what you want to see. Any other comments or questions that you want to see? What if the function is doing more complex works, not exactly replaceable by a simple expression? You'll have to be, if you can give an example, Judith, that might help kind of show what you mean by that. Okay, so Luke, can you use the values passed in to generate the output? E.g., get item value gives a static. You can inspect things that you've passed. If we just kind of go, let's go back up here. You can do kind of if-then case expressions and so on inside here. If you're starting to get very complicated, you're probably, abusing what you should be doing in a macro slightly. So you need to be careful about what's going on. But yes, you can do like case expressions and things like that in here to see what's going on. Okay, so I don't really get it. Expression replaced by a function, which is in turn replaced by an expression. Okay, so the key difference is when you call a regular PL SQL function, you pass it some values, it calculates the result, and it passes you the result back. for the person calling it, it is in effect a black box. It could be doing anything in there. You don't know. You don't care. It's, you know, you pass it some values, you get something back. With a SQL macro, you are passing some placeholders essentially and saying, pass me back the expression. So the text that will become part of the final SQL statement. You're not saying calculate the result. You're saying, give me what the calculation will be so I can put it in my SQL statement. So this avoids that context switch problem that we kind of were talking about before with performance. Okay, so hopefully that can help. So Shankar, I hope that explains it. Avoids no context switching is the benefit. Okay, no. So no context switching is one of the benefits, but the other thing as well, you've got the full power of the SQL engine. Like I say, with a PL SQL function, as far as the optimizer is concerned, it's basically a black box. It doesn't know what's going on. Things like estimating cardinalities and if you use Exadata, smart scans of stuff that happens inside a function, you know, the optimizer just doesn't know it. The SQL engine doesn't know what's going on there. So it's a black box. With the SQL macros, because it is part of your SQL statement, all the optimizations and power and so on built into the SQL engine then become available to you. So it's, you know, potentially it's more than just no context switching. It's also enabling potentially a whole bunch of other performance benefits. You know, there's a big stack of list of things that could go on. Okay, I see there's lots of other questions come in. Let me see. Yeah, Stu, can we just ask questions about scalar macros for a moment? Some of these questions refer more to table macros. I think that's a good point, Stu. Like I said, I've got a lot more to talk about, so let's, I'll just flick through some more. So Alex, so has something more in common with row-level security predicate functions, we can control what the query will look like. So Alex, keep that in mind as we talk about table functions. So that might explain a bit more. And Sven, with column equals parameter or parameter is null, the parameter is null, then I would like to expand the query to have no filter. If the parameter is not null, I want the query to expand to column equals param, so without the OR expression. Okay. I'm not sure off the top of my head, Sven, about whether we can do that so it alternately does one or the other. I'd have to think about that and check it, but I'll look into that. All right then. Okay. Tado, see more clear, instead of being called a function, is simply a macro. Probably a fair point, but we're here now. I think it's, you know, where we are at. I don't think that's changing that soon. So Luke, in this example, it doesn't matter what you pass in, i.e. pass in garbage and you would still get out the static unit price times quantity. Is that right? Okay, so if I go back down, so we've called get item value. I passed in the columns here, unit price and quantity. And in this case, they're columns, but they could be literal values. They could be buying values or buying variables. Whatever you pass in essentially becomes part of the SQL statement. So these here, it just so happens that the names of the parameters match the column names that I've got. But I could have called these parameters anything. And actually, it's looking at the parameter name for the function and using that. And then whatever it is that we pass, could be a column, could be a literal, could be a buying variable, that is what becomes part of your final SQL statement. So hopefully does that help explain it, Luke? So no, if I passed in the columns, what else would be a number? Customer ID and order ID. It would be then, this would be customer ID times order ID. Okay. So at last, it will be a simple text replacement. That's it, Niels. Okay, so let's move on a little bit. So there's some good questions, and I'll move on a bit, and hopefully I'm sure you'll have more, and it might answer some of the ones we've already got. Okay, so we've got a SQL macro. Now, you can base SQL macros on SQL macros, right? You know, in PL SQL, you can have a function which calls a function. You can have a macro which calls a macro. So rather than return just the value, what I want to return that value as a formatted number. So add a currency, so dollar, and then some zeros. So I need to char this value and give it a format mask. So what I'm going to do is create a new function, getFormattedItem, with an optional format mask, and this calls that getItemValue SQL macro. So we've got a macro which calls a macro. When you then use this in your SQL statement, the database fully resolves the whole thing. And so if we write this, get the formatted thing, and I'm not quite sure why you'd write something like this, but let's forget that for the moment. So we've called the formatted item value. Well, that does the to-char replacement and then figures out what the get item value is as well. So it does that replacement too. So the statement ultimately is this. Like I say again, this is, you won't really see this. This will just be hidden from you. You'll just see get item value. But what the database really executes is this. So you can base macros on top of macros. So it's, you know, this gives you reusable components. If you've got a lot of these kind of formulas that you're going to be using, where you can just define them in, you know, have a package where you define all of these and actually reuse them in your SQL statements. If any of you do a lot of kind of scientific analysis, there's whole stacks of formulas for calculating things like speed, acceleration, so on and so forth. You can define a package which has all of those and use them in your SQL statements without potential performance issues that we had with regular PL SQL functions. Okay. So, all right then. Okay, let's move on a little bit. So that was talking about scalar macros. Let's move on to look at table macros. So let's think about parameterized views. Well, let's just talk about views generally. So I think views are generally a great, really useful thing. They give you reusable pieces of SQL, making it much easier to understand your statements. So you can take a big complex set of joins, for example, just replace it with select star from view. So that's great, but they can be a bit tricky to reuse. So for example, we've got a view here, and in there is an analytic function. We're getting the running count over the rows. So, well, why is this a problem? Well, the problem comes when you want to filter these results. So we've got our view with this running count in it. So when you do the filter, there's two places we could do it. Now, at first glance, we've got two things that look similar here. We've got select with a running count, but they've got two different where clauses, or the where clauses are in different locations, I should say. So on the left, what we're doing is filtering all the rows and then getting the running count. On the right, we're getting the running count over the entire data set and then filtering the results. So a couple of issues here. First up, in general, these give different answers. Okay, so this on the left, the running count is always going to start at 1. Over here on the right, you'll get the running count for your entire data set and then the subset of that. So that count could start anywhere. Could start, you know, if you filtered halfway through your data set, you could be 500 million as the first count in your results. So in general case, these will give different answers. And if you've got this in a view, then you are in this second scenario where you're doing the count first and then filtering the results. So different answers, first problem. Second problem, performance. As I said, on the right here, we're having to produce the count across the entire data set. So if you've got 10 million row table, we're counting all 10 million of them, then doing the filtering. Whereas on the right, we're only finding, the 10 rows we're interested in and producing the count across those. There are two problems, different answers, and the one on the right is typically a lot slower than one on the left. Exactly which of these problems you notice first depends on how good your testing is and how big your data set is, but usually spot one or the others of these pretty quickly. Now quite often with these views, you kind of go, well, the thing you really want to do is filter and then count, because that's the answer you want, but also it's a lot faster. So usually you want to do this, but if you've got this in a view, you're doing the thing on the right, which makes views less reusable. And then people start doing things like putting views on top of views and wondering why things have all fallen apart, because usually somewhere in there they've done something on the right when they wanted to do something like on the left, and ended up with different results and much slower queries. So with table macros, we can kind of get around this. We can inject the parameter in the subquery. So how do we do it? So I'm calculating running totals here. So I've defined the SQL macro as a table. Now here, what I'm returning is a SQL query. So it's a select statement, and we're selecting, the count sorted by classic HR employees table, running count sorted by date. And I want to filter those on a particular date. So we've got the hire date. So notice I've prefixed this running tots, that's the name of the function, hire date. So whatever the thing we pass in for this then becomes part of the SQL statement. So from Udis saying, it's still not clear whether the input arguments are really needed. The key point here is whatever those arguments are become part of the SQL statement, okay? So if I pass in sysdate, then it becomes where hire date is greater than sysdate. If I pass in a bind variable, it becomes where hire date is greater than whatever that bind variable is. If I pass in some other column, it's where hire date is greater than the column name I've passed in. The actual thing that you pass as the parameter is what goes here, okay? So that is what's going on there. So if we then calculate that running totals, so we can just call that in our from clause like this, pass in the date, and we will get some output that looks like this. Okay, so some other questions. So Udis, I hope that's explained this. Basically, we've got this date here. Do I have a bind variable example to show us? Well, not to hand immediately, but imagine, so I've got here this running totals, date greater than this. So we take that date, 1st of March 2008. This query, essentially, we were replacing this with the 1st of March 2008. Okay, so this value here is this. It is exactly whatever you've passed here. If this instead was a bind variable, to date, colon date, blah, 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 that is what would become here. If I pass in a parameter, does it pass the value? No, it's not the value that it's passing. So this is really just a text expansion. It's not a traditional function. This is not executed, okay? So like I say, if I've got, now, let's see if I can think of something quicker. So I've got this here. If I take that date and I change that to anything else, I could pass it. So if I pass in, so instead of saying running total date, I pass in sysdate, okay? Then the SQL query we run is select count star over order by hire date from HR, where hire date is greater than sysdate. Okay, it's not passing the value of the result of running sysdate. It is literally passing sysdate the function, and then we run the query here as if it was sysdate itself. Does that help explain, Greg? And again, I could replace this with a bind variable, and it would be, and we define hire date as a date type. I have in this instance, which would mean it would be something that returns a date, but you could make it varchar, so you've got polymorphism, in which case you could pass in anything, basically, that you want, but it gets used as hire date string. You can pass these as varchar too, or you can say you want it to be a specific, something that resolves to a date. But you get polymorphism, so you can pass in anything. So where higher date is greater than what's a function that power, that or something else that returns a number. Yeah, you could do that, but of course this whole query is not going to work because then we're comparing a date to a number, and the query is going to fail. You're going to get data type conversion error. So yes, you could make it a varchar 2 and accept anything, but then what does that mean for what's actually going on in here? Some things you can do that, you can pass in anything, some things you can't. Any other questions on that? Okay. Just pop back up. So I see a question from Burks. Will the real SQL be visible in $SQL? So no, in $SQL, you will see the SQL statement that you sent to the database. DBMS utility expand SQL text, you can use that to do the expansion of the table macros, so you can see what it actually did. So you can use DBMS utility expand SQL text. That and running the lovely 153 trace, which is not something you really want to be doing every day. Those are the only ways I know of, at the moment at least, to see what really happens. Yeah, okay, so you're just saying it's not clear how it can replace a parameter inside of a quoted string. And so Niels' response, I think you've got this right. So as he says, it's like creating a string for execute immediate with placeholders and then finally replacing the placeholders with field names or bind variables. That's what macros do. And that, that sounds right to me, Niels. They say this is just a placeholder. The SQL engine itself is doing the replacement of, it's saying, what did I pass as a parameter here? And do a literally, like a replace textual replacement of this thing with whatever it is you actually passed. Freehold. I think SQL Engine now has a preprocessor and macro is a part of it. I'm not sure what you're getting at there, Freehold. But I mean, the SQL engine always had like the parse phases and so on, and it's just that SQL macros are now fit into that process. So I'm not sure I understand your question exactly. Okay, let's move on. Okay, so I can see this is some of you getting perhaps a bit confused with this. Be ready to have your minds completely blown. All right, then. We can now have polymorphic views. So we had parameterized views, where we're passing something in and it become part of the where clause. But we can also have polymorphic views, where we can pass in a table and return different tables. Whoa, okay, this is getting scary, right? Okay, so how does this work? Okay, then. So what I've got a thing here is I'm going to add a count to the results. I'm going to column count star over, and I'm going to do it on the dictionary views, like all tables, all views, all procedures, and so on. So partition by owner. So for each person, partition by that and produce a count for each schema. So, and we look here. The parameter here is T, a table, DBMS TF. If any of you played with polymorphic table functions and so we could pass in tables there, it's the same concept. Okay, we've reused that concept from polymorphic table functions to have polymorphic views here. And whatever that table name is becomes the table name. Okay, so if I pass in add count and pass in all tables, well, there we go. We got our count of how many objects abcusis, whatever the schema that is. So that's got 5 things. We pass in all tables. We can also pass in all procedures. We're literally passing in the name of a table. And because this is, in SQL, everything is a table, you can also pass in a subquery. So if you've got a with clause with a named subquery there, you can also pass that in as well. So you can do some filtering first and pass that in. So this is dynamic. It's basically saying, take the query we had before and run it as if we'd passed in all tables there. So just, if we go back up, replace T with all tables, okay? Okay, so this is good. We got account for owner, but what if I want to change which column it is? Well, we can also dynamically pass in columns as well. So again, reusing the concepts from polymorphic table functions, we have the columns pseudo operator. You can pass a comma separated list of literals, which are column names. We can make that part of the SQL statement as well. Okay, so we can do something like this. Pass in a table, say columns, table space, name, and then it's producing the count here, not by owner, it's by table space. So how many things are in that table space? Oh, thanks. All right, that's you has figured out what the app quotes is that user is an internal database user schema for exclusive use by the quality of service management functionality. That must not be removed. Thanks, Sven. Okay. Okay, so Niels, like today said earlier, please change the syntax to create or place macro. All right, I see what you're saying. I think it's probably a bit late in the day for that to happen, but point taken. I'll see what we can do about if there's any chance of that happening. I suspect no, but we'll see. Okay, so let's see if I miss anything else. So Judith, ultimately, it's a way to achieve dynamic SQL using static SQL syntax. Kind of, not. That's probably the closest to it. It's not exactly dynamic SQL, but if that helps you think about it, that's probably a good way. All right, I think any other questions or comments on this? But when you use C1, you did not put it inside the quoted string. So this is pure PL SQL, making replacements inside the quoted string versus, okay, so this is slightly different. The columns here is an array, okay? And SQL doesn't talk PL SQL arrays. It doesn't know what they are. I forget exactly whether I think it's an associative array, I forget. But SQL doesn't have that array, or at least Oracle SQL doesn't have that concept, so it can't do the replacement. So it doesn't know what's going on. So here we're passing the first element of the array, which is the column. So that's why there's a difference here. Okay, because it can't just take that array and partition. You can't. In any case, you can't partition by an array. I mean, what does that even mean? I don't know. Okay. Any other comments on this? Whose mind's blown at this point? You're just going exploding. I have no idea what's going on here. Who? More like dizzy. More like dizzy. Okay. Or who is lying? Yeah. Okay. So, though more verbose, I think that semantically more correct to only make replacements at the PL SQL level. Judith, I'm not sure what you're referring to there, but are you, instead of saying create replace macro, for example, any other questions or comments on this before we move on? I'm just imagining someone uses this stuff and then I get called in to maintain it. Yes, so that is concatenating the parameter outside the quoted string. Okay, I'm still not quite understanding what you're referring to. I mean, you're referring to this example specifically. All right then. Well, I think okay. We've still got quite a bit to talk about, so I think we need to move on. As I say, when 20 C's out, you get to actually start playing with this. Expect a lot more examples. Clearly this is something which is very cool, very powerful, but it's going to take a fair few examples. So there will be a lot coming when we eventually when 20 C's out. Let's move on. We're looking at analytic functions. Let's look at window improvements. So these are really cool. I really like these. Okay. So I see there's more comments. If we've got time at the end, we'll come back to these, but there's a lot to talk about on window improvements as well. So we need to move on. All right then, so let's imagine you asked to do this query. You want to get the running count and salary for each department sorted by the hire date. So we'll use, again, classic HR employees table. So we're partitioning by department, ordering by hire date, sum and count. What's the problem here? Well, we've done exactly the same thing in both of the over clauses. You know, duplicating work, just making things harder to maintain, and so on. Be kind of nice if we didn't have to do that, right? If you could just define what that window was in one place. Well, very soon you'll be able to do exactly that. There is a new clause for SQL statements, window clause. Okay, so how does this work? Well, rather than over, brackets, partition by whatever, we can just say over W. And because both of these have the same window, we then define the window at the bottom of the SQL statement. So this will come after the group by, having by clauses. We can define our window as partition by department ID, order by hire date. So now both of these analytic functions use exactly the same window. So if we want to change it, we just have to change it in one place, making things a lot easier to maintain. So John, I think MySQL has this now as well. I know other databases do have this. I'm not sure exactly which, but yes, other databases do have this too. Okay, so we've got one place to define this, but even cooler than that, we can chain these windows on top of each other. Okay, so we can start off by saying a window called, which just defines a partition by. So we're just partitioning by the department. We can then refer to that window in another window. Ooh, this is really cool. So we can define a new window, ord, and it uses that window part. So this implies we've got partition by department ID before it, and then ordered by the hire date. So we've partitioned, we sorted. Well, there's the window clause as well itself. So we can say how many rows, range, whatever we want to look forwards or back. We can define our window using that order as range between 28 preceding and the current row. Find everything in the previous 4 weeks. So these chain up on top of each other. So we can have multiple of these, and they can refer to other windows as well. They do have to follow the normal analytic function ordering rules. So you have to have partition by, order by, window clause. We can't rearrange them to kind of jumble them up in some other way. But this is then potentially very useful. We might have lots of functions partitioned by department and then several different sorts on them, for example, or something like that. Or we might have a standard partition and sort, but different windows that we want to show for each one. Show me the previous week, the last month, the previous year, and show those as 3 separate columns. We can define a standard partition and window sort, and then tack on the window as needed. So we can then refer to those in SQL statements. Very powerful. Any comments or questions on this at this point? I'll just look back, see some of the comments, main issues. Feature. Love it, +1, there we go. Shankar, can window W be defined over multiple tables? I mean, it's +2. Very good feature. So, I mean, these are just normal window clauses. So you can't define a join in here, but if you've got, in your statement, you've joined 2 tables, you can refer to a column from each, partition by one, and order by a column from the other table. You can do that. So as long as they're part of your original SQL statement, yeah, you can do it. So not all the columns have to come from the same table, but they do have to be part of the SQL statement that this is, it precedes or is below. IMO, it looked forced in the trivial case, but when you have, say, 100 columns doing it, it will be great. Yeah. I mean, I think a good use of this will be things like statistical analysis. Let's say you're doing, quite often, if you're doing stats analysis, you might want to get the min, max, mean, standard deviation, blah, blah, blah. They'll all have exactly the same window. So just having one place to refer and define to it, very useful, very neat. Okay. Any other comments related this. Okay, so we've got this window clause. It's a standalone clause, but we've made some other enhancements to how we work with analytic functions. So let's say you've got this query you want to answer. Show the income, the total income for the past 5 days worth of sales. Sounds like a straightforward query, right? Well, there is a bit of ambiguity in here. So when we say the past 5 days worth of sales, do we mean 5 calendar days, so exactly 5 days, or the last 5 days on which we actually had orders? So to kind of illustrate why this might be different, let's imagine you work for a business which is shut over the week on Saturday and Sunday. So you never receive any orders on Saturday and Sunday. So those are always going to be, you're always going to have 0 on those days. Today's Tuesday the 22nd. If we go back 5 calendar days, you'll go back, including today in that count, we'll go back to Friday last week. So that's 5 days, but we've got 2 days here we're never ever going to get an order on, okay? We want the last 5 days on which orders were placed. So actually, we want to skip over Saturday and Sunday and get the totals over these 5 days. Slightly subtle, but it is a big difference here. So how do we do this? Well, it's kind of tricky with standard analytic functions. You've got the 2 ways to define your window in terms of rows, a specific number of rows, or a range of values. And with rows, okay, we've grouped our orders first. We might have 5 rows here, but what if we want to see the individual orders themselves? There could be any number of rows here. Range, well, it's really tricky to do this because sometimes it will be 5 days and other times it will be 6 or 7 days. Particularly if we include other types of public holiday, maybe Christmas Day, New Year's Day, those type of things, we don't know exactly when the earliest date is going to be. Very tricky to do this with these. So there is now a groups frame for windowing clause. So how does this work? Well, you've got your order by, and then you specify your column, and then you say whether it's rows, range, or groups. So groups is new. And what that means is consider rows with the same value for the sort key to be one group. So best illustrated with an example. I've got a whole bunch of rows here, and there are 3 groups. We've got one group where the values have the 21st of October, second group, 3 rows, 23rd, and the third group is the 25th of October. So 3 separate groups. Rows which have the same value for the sort key. So we're saying order by whatever this date is. Okay, so how do these things differ? Well, if we consider this row here on the 25th of October, the one near the bottom, if we want the 2 preceding rows, that means we will get exactly 2 rows before this. So it's those 2 rows on the 23rd of October. Note, if this was the first row in the data set, there is no previous. So, that's why I say up to 2 rows. So 2 rows preceding. We're going to get a maximum of 2. And we've wanted to include all those dates up to the 23rd. We've missed that. If we specify as range 2 preceding, we now take this date, subtract 2 from it, and we include all the rows from that date, so the 23rd, up to the current date. Notice we now also include the 21st of October after the current row. So it's all rows with the same value as the current row and whatever the range is before it. Groups, however, it says, consider all rows with the same value distinct sort keys. So we had 2 prior groups here, 21st and 23rd. Those were our 2 prior groups. So we include all the rows in the data set here because those are the 2 prior groups and all the rows with the same key as the current row as well. So this includes the entire data set. So this is potentially very useful in situations where you might have some holes in your data which are missing. Range doesn't cope with that, and rows, again, if you got multiple rows for a particular sort key, just doesn't work at all. So groups allows us to solve this kind of problem. So 3 things, what's the different approaches here? First thing to notice, with the range approach, we can only have one sort key. You can only order by date. You can't do order by customer ID and then date, or multiple things. Secondly, it has to be what we call an additive data type, something you can do maths on, basically. So number, dates, and intervals. You can't use range on text values. What does it mean to say find the two prior things before the text hello? I don't know, it's a bit of maybe a philosophical question, but it's not clear what that even means. So range, you can only sort by one column, and the values have to be additive, so you can't do this on a bar chart. But it is deterministic, unlike rows, which you can do on any type of sort key. You can have any number of columns in your key, but it is non-deterministic. If we go back to our previous example here, two rows with the 25th, they've got the same value. So this is non-deterministic if that's the only thing we're sorting by. We might flip those around accidentally. So rows can be non-deterministic. Groups is kind of a bit of a hybrid between the two. You can have any number of these, you can have any sort keys, and it is deterministic. So, okay, so Judith, this is indeed a new quality, but they should be better called values than groups. Argue that with the SQL standard people. This has been decided, and that's what the SQL standard calls these. So, plus values is already a keyword, or for SQL in terms of insert. So I'm not sure that would be a good choice either. So groups is what this is going to be called. Okay. So another thing we can do with this, frame exclusion, exclude particular rows. And there's various options here again. So we can exclude the current row, ties, group, or no others. So this is another new clause which will appear after the end of your window. Exclude no others is the default. That's behavior you have today. So how does this work? Again, best illustrated with an example. Let's return to this 25th of October. And I'll stick with the groups frame for this. So we say groups to preceding, exclude current row. It's probably the easiest to understand. Just omit yourself from the results. So don't include your own row's value in whatever the calculation is you are doing. So exclude yourself from the frame. So probably the easiest to understand there. Next, exclude group. So remove the current group from the frame. So that is all rows with the same value for the sort key. So here, that's both of those rows with 25th of October. Okay. And again, fairly straightforward. Ties is probably the one that's a little bit trickier to understand. So it's remove rows with the same sort key as the current. So we can see on the 25th, there is another row for the 25th of October. So that falls in the same group. So this second one at the bottom here is tied with that first row there. So we exclude any other rows which have the value 25th of October except the current row. So this is potentially useful. Quite often you want to get over the previous values and include the current, but not any of the others which have the same value as the current. So ties means include current row, but not the ties. That's right, Sven. So when you say exclude ties, include yourself, but exclude anyone that has the same value as yourself. So whereas exclude current row is kind of the opposite. Exclude yourself, but certainly with the groups keyword, include anyone else that in that group. So that's it, Sven, you've got it. Any other questions or comments on this? Is there also a full groups between format? Yes, you can use the existing window format of groups, between 2 preceding and current row, or 2 preceding and 10 following, or whatever you want. I've just used the shortened syntax just to make the slides a bit more readable. But yeah, groups support the full window frame that you have at the moment. So you can specify the end of the group as something beyond the current row. So you can do that as well, yes. Any other questions or comments on this? Full window frame. Oh, John. Yes. Alrighty then. Okay, if you've got default group equals window. I'm not sure quite what you're asking there, Shankar. If you're asking what the default window is, it's still whatever the current one is, which is range between unbounded preceding and current row, I believe. So the default is just what you have currently. Okay, we're getting close to the hour. There's one last thing I wanted to cover. Luckily, this is a fairly quick one, and that's some new set enhancements. So these are just some little tweaks to the existing ones. So you're probably familiar with union. Use it every now and again, certainly if you have a recursive with or union and union all. We've also got intersect and minus. We will now have an all option for those. So instead of just a plain intersect and a plain minus, which do a distinct operation, there is the all variants of those. So a bit like we've got union and union all, we've now got intersect and intersect all. There's also except and except all. Those work exactly the same way as minus. We just added them for SQL standard compatibility because that's what the SQL standard calls this operation, except, not minus. So very quickly, I'll show you how these work. So we got our two tables here, say table 1 on the left, table 2 on the right. And you can see there's quite a few rows which exist in both data sets, and some which are only one table but not the other. So if we do a standard intersect, that will do a distinct first, then return us the results. So if we intersect those, we can see they both have the value 1, 1. So we get 1 there. Note, null, 1 null. Nulls are considered equal for the purposes of these comparisons. So we get those rows, 1, 1 null, and 2, 2. Now, if we do an intersect all, we then get that second row because both of them have a row 1, 1. So it does a complete comparison, how exact match on the number of rows with those values. If we look at minus, so there's only one set of values in our left table which doesn't exist in right, which is those nulls. However, we can see with the 2, 2, there's 2, 2, 2 rows with the 2, 2. It's getting a bit tricky to say. The left table has 2, 2 twice, whereas the right table only has it once. Because we're doing a distinct operation on these, it doesn't appear in a standard minus. We do minus all, on the other hand, we've got this extra 2, 2 row in the table on the left, which is not on the right. So it does an exact for the number of different rows comparison check whether these are all the same. So this is just a little feature. Whether or not you use it, it's still a nice little addition. Any last questions or comments on those? We're getting close to the hour, so we've got time maybe for a couple more questions. Let's see. Judith, they work like multi-set ones. I guess, yes, it's the same. If there's the multi-set, intersect all, union or minus all, or is it except all? Same functionally, or it's the same principle. Yes, you're right there. Oh, minus all might give debugging troubles. Yes, it's true, because let's say we've got this 2, 2, which of those rows actually is it? Well, yeah, okay. You have to think about what it is exactly you want to get here. So with minus, essentially we do a distinct on each table first, then do a comparison, whereas minus all does a row by row comparison of the two tables. Evangeline, what happened to 3, 3? Okay, so we're doing the left table minus the right table. So everything that is in the left, but not in the right. If we do the reverse, everything in the right, not in the left, that's when we get 3, 3. It's because we're going left to right. That's why we don't get 3, 3 here. If we go right to left, then we get these 2, 3, 3 rows, but not 2, 2 and null, null. So I hope that explains, Evangeline. But by default, probably remains without all. That's correct. Judith, default behavior stays as is today. So the kind of distinct versions of those, you need to add all if that's what you want to say. So you're not going to upgrade, and this is all going to change on you. Okay. Any AMA, they work performance-wise. Well, it's I haven't done any particular testing, but first thing is it's going to run both those full queries. You know, if you're doing an intersect or a minus on two 10 billion row tables, well, it's got to read all of those 10 billion rows from each of them. So two lots, so 20 billion rows. Might take a little while. Okay, so you know, it's always one of those. It depends. Think about the data you're actually reading, but I haven't done any specific performance testing beyond that. All right, let's go. Yep, lots of new stuff. So there are quite a few other SQL features which are planned for 20C. These were just my favorite and the ones I think you're most likely to actually use in your day-to-day job. Some of the others are a bit more esoteric, but just wrap up, say thanks for joining us. Hope you learned something, and the recording will be available. See you next time. Okay, thank you all.